So this is the Rick's Repo Rundown for IS sessions on May the 19th of 2020. I can't be there this week, so I'm pre-recording this. This week's repo is a project called ReconPi, which is basically like a big bash script that installs a ton of reconnaissance tools onto a Raspberry Pi. The idea is that you supply it with a domain name and it will scan that domain with a bunch of different tools and provide you with some reports and output, hopefully to use as sort of like a precursor to a penetration test. Tools here at the link on GitHub, and the author was X1MDev, or I don't know, ZimDev. I'm not totally sure how you're supposed to say that. So the author's description: a lightweight recon tool that performs extensive reconnaissance with the latest tools using a Raspberry Pi. And I mean, the joke about people having lots of Raspberry Pis sitting in a desk somewhere, and that this is, something that you can actually use your Raspberry Pi for, which is great. And it also says version 2.1 is now usable on your VPS, which is great because you could just deploy this onto a server and hopefully, run it from there instead of just off of a Pi, which is super useful. Installation is pretty easy. Just connect to whatever the host is, and basically the GitHub repo hosts an install script that you can pipe right into Bash if you want. You should probably just have a quick scan over it and make sure that it hasn't been patched maliciously before you pipe the install right through Bash. You don't actually need to clone the repo. The install script actually takes care of grabbing what it needs out of the GitHub repo for you. But basically, my sort of rundown of it is that it's one giant bash script that throws a bunch of tools against a domain and generates you some reports. So the usage is pretty straightforward. You just type recon.sh and then you point it at some domain, right? So facebook.com or whatever. The idea is it runs a bunch of what they call, or it gathers a bunch of resolvers to give you access to a bunch of DNS data. It tries to do subdomain enumeration, so www.the you specified, mail.the you specified, dev.the you gave. So it does a bunch of brute forcing and use lists to build a list of potential subdomains. Also gives you lists of ones that maybe you could take over, so a domain that's there, but there's no registered domain name for. Maybe you can go register it to hijack it. It'll try to find IPs associated with that and then enumerate them and port scan them. It will also try to visit any web-based targets that it finds on those domains and subdomains and sort of use the automated browser screenshot taking to build a collection of data that way that you could maybe use for determining the endpoints and web application vulnerabilities, things like that. When the scan is finished, you run this Python line. Python comes with a project that's a built-in HTTP server, and you basically turn this thing on and it will show you where to get the results for your scan. You can also configure this thing to throw a message into a Slack channel when it's done scanning, because if you enable all of the functions in this, some of the scans can be quite time-consuming. It installs a lot of tools. This is the list off of the GitHub page of stuff it installs. If you start looking through this list, again, you'll see a lot of stuff for subdomain enumeration, things for accessing, websites on domains, scanning the websites themselves, looking for various assets like JavaScript files, tools to then parse those JavaScript files for links to other resources on the same site. There's port scanners like MassScan and Nmap. There's the wrapper for Shodan in Python. It pulls down word lists from sec lists to use for brute forcing. There's fuzzers, there's a vuln scanner. It loads up a huge collection of tools, and what's interesting is a lot of these are actually written in Go, so they're pretty fast. Especially stuff like GoBuster, which is the Go implementation of a tool like dirbuster for finding file paths on web servers and in web applications. So basically, it calls these functions. The big script calls these functions in this order. So gather resolvers, so DNS resolvers. Gather subdomains, meaning find all the subdomains associated with this domain. Check takeovers, which is looking at the subdomains to see if any are vulnerable to a takeover or if they have been taken over. Get CNAME records for the domain, so other aliases basically. Gather IPs associated with the domain. Gather screenshots of stuff you can navigate to. Start Meg, which was, sorry, I forget. Meg was a distributed dirbusting tool, right? So start doing dirbusting, fetching more of the data from the application and the results of some of the previously run tools. Fetch the endpoints was looking for things like API endpoints that the websites might have that this thing is hosting. Run nuclei, which is kind of like a vuln scanner. It makes more sense if you read through the project, but you can specify like templates to allow this thing to capture more detailed information from endpoints and sites. And then it runs a showdan check, the port scan, and then it dumps the notification into Slack if you've configured that. So the way this thing is organized, so the repo itself is really simple. There's one folder with a word list text file in it. That's just a big word list that can be used for brute forcing. And then there's 3 actual files outside of the standard GitHub stuff. There's install.sh, which is the installation script. There's recon.sh, which is the actual program itself. And there's tokens.txt, which is kind of like a config file. So for example, if you do want this thing to dump a notification into your Slack channel, you have to put like your Slack key into this tokens.txt file, which is parsed by the recon.sh script, along with some of the other tools that might need a key. Basically just won't run stuff if you don't supply the keys for some of those services. So the way it works, if you run install.sh, first off, it prints a logo. We all love ASCII art logos, and it's essentially lots of what you see on the right-hand side of the screen here. So like, git cloning repos, doing apt install for prereqs. A lot of these tools are either Go or Python, so running like pip install, or Go's package manager, which is like go get and then some package name. And it just adds it all somewhere in the root of your home directory. Restart services if required for containerized applications and stuff like that. A couple of more specific tool installation examples. So on the left is installing Rob Graham's mass scan tool, which is like a really, really fast port scanner. And so it just grabs it from GitHub and then makes it, and that's kind of it, along with the dependencies. It's neat the way they use mass scan here. So they mass scan the target first to find out which ports are maybe available, and then runs nmap on only the ports that mass scan reports are as being open. So you're not like using a ton of time with nmap. You're basically doing the mass scan first and feeding the results of that to nmap, which is kind of cool. And then on the right is an example of it installing showdanify using like pip and cloning the GitHub repo and stuff like that. The main actual recon.sh bash script, and the reason I wanted to do a bash script this time instead of Python program is that one, I don't know, just haven't done bash in a while, and two, this one's got some good examples of how to do a lot of like batch installation and batch running of tools in a giant script. There's some good practices in here that someone could follow. So initially it sets a bunch of variables. So these ones here are actually used for like resetting the terminal and coloring terminal output, which is always really handy because some of these things can be annoying to write into scripts. So having them in variables is really easy. And then the rest of the variables are essentially directory locations where results will be stored for the various applications that are installed. Then the application just checks to see if you provided it with a command line argument, which needs to be the domain that you want to scan. And if you didn't do that, then it just spits out a warning message. This is kind of how you, you can check to see if there's args. And then there's just a bunch of function names similar to the order of operations that I listed here. There's basically a function name for each of these that in turn calls all of the individual tools to gather the data for you. So gather resolvers prints a little message that says, hey, we're starting the gathering resolvers phase, and it'll run this tool, BAS or base, I'm not sure how you're supposed to say it, and grabs any of the data and dumps it in ips/resolvers.txt as an example. And lots of the tools are essentially run like this, as a little function with some kind of logging detail, stuff to note like cd into home/tool/base or return, which is kind of interesting in terms of how we're structuring this giant batch script. So here is how they're kind of automating printing out messages and resetting the color on the terminal. So basically it'll say in green text, it'll say done, then next, and then it will run the next command. So again, just more examples of how it is batch running the commands here, which is really useful because I think it's installing the commands into this subdirectory in your local folder, and then it's executing it out of there and dumping the results into some location. So that one was subdomain finder and asset finder, which finds like other assets on a list of URLs. gather IPs, so this is where it's checking against the subdomains and getting the IP addresses associated with those and dumping them out for you. Here's the port scan. So as you can see, it grabs the IP list that it generated in the previous step, and then is feeding that into masscan. And masscan will dump the reports into a file called ports, I think. Or it dumps it into a result called masscan, and we parse that apart and get all the ports. And then just the ports with the IP address are fed to Nmap for more detailed scanning results on those ports. So that's kind of how the port scanning works, which is neat inside of a big bash for loop. Here's running a tool called Aquatone, which is automating the taking of screenshots from the various hosts that all of these subdomain and IP scanning found. So it basically simulates, navigating to that page in a web browser and taking a screenshot, and then dumping that into a directory for you. Fetching endpoints will run this link finder thing, which parses through like JavaScript files, for example, and it tries to see if JavaScript is making calls out to any API endpoints, because those would then be associated with the web application, and it stores those in a text file called endpoints as well for later searching and analysis. Here's it running, for example, some of the directory brute forcing with GoBuster. This is a wild command line, so it's taking all the hosts that you found and then running GNU parallel. I think that means like 5 cores, and giving you a status bar, and then running GoBuster. So like running like 5 instances of this, or running GoBuster in parallel with the word list that is located in the repo, and then dumping all the results to sub.txt. So it's basically going to try to find all the file paths in that web application or on that host that you found. When it's done running like that huge collection of tools, and I've only provided like a sample set of them here, but when it's done running that, then one of the last things it does is run this make page function, which basically, one of the previous steps was to install the Nginx web browser on your device, whether it be like a VPS or your Raspberry Pi, and then it starts to build a simple HTML page of all the results. Like it dumps all the screenshots into a location, and it basically gives you links to those on the web page. And then it kind of tells you where to find all the results for your scans and stuff like that. And then the last thing it does before quitting, if you've configured it, is to dump a notification into your pre-configured Slack channel, which it does right here because Slack's got an API, so it just makes post requests into Slack saying, hey, ReconPi is finished, here's where you find this info, here's where you find this info, here's where you find this info, and so on, which is kind of cool, because obviously some of those operations like the nmaps and all the go busting will take a long time. Who knows, it could take upwards of a day or two. So you want to be notified when this thing's finished without maybe having to check back at the VPS every so often or at regular intervals. And that's really the repo this time. I like it as an example of a really clean, modular, well-organized, gigantic batch process where a whole ton of tools get installed and configured for you, and then are all executed in a really logical way using the output of previous tools to inform later tools, and really automating a lot of tedious manual domain research that you would probably have to do before starting a pen test. I think it's really great. And that's this week's repo. Hope you enjoyed it. Thanks.